Okay, this is the Unit 5 Mastery Project FRQ. So, number 1, Part A, state which laws or equations you can use. This one, since it's about momentum and about the velocity after it, you can use the conservation of momentum. And the equation for that is mvi plus mvi equals mvf plus mvf. And then number 2, derive an equation that relates to the initial height, blah, 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 collision in terms of mx, my. Okay, so you start off with initial momentum equals final momentum. And since they both have an x and y, since it's not a perfectly horizontal collision, you have to do px sub 0 plus py sub 0 and px f plus py sub f. And then from there, momentum is just mass times acceleration. So mass of x times, or mass times velocity for momentum actually, times mass times y. And then for this one, since it says that, since it says at which the two-block system travels after the blocks collide and stick together. So since they stick together, then that means they'll both have the same final velocity because they're stuck together. So you can do this, and there will just be 1 VF. So after you do this, you can use the equation, VF equals 2GH. And then you can isolate this equation. And then just doing a bit of algebra, divide it over to get mx. And there's only one initial velocity now. So 2GH over mx plus my. That's your answer. Okay, part B, design an experimental procedure. So okay, so you have, let's see, what do you want to measure? Relationship between the height and the speed that the blocks, from when the blocks are sticking together after they collide. So to do this, you obviously need the height. I'm just going to do height symbol h, the equipment meter stick. And you're going to need the velocity too. So velocity symbol v, equipment motion sensor. And then, so yeah, now I can make your procedure. So let block slide from ramp have blocks collide, record new velocity. Oh, and you have to measure the height. And then use data to determine, oh, and then, actually not this yet. do 3 tests on each height, and do 3 different heights. So I have 9 trials total. And now you can use the data to determine if there is a relationship between increased height and increased velocity, or vice versa. Okay. Let's see. Next question. Where'd it go? The collision between block W and block C is not perfectly elastic, even though they remain stuck together. Because one of the blocks might have caused a deformation. Oh wait, where's the question? Okay, I think it's like, is the equation perfectly inelastic, or let me find it. Okay, why does the predicted speed of block Z after the collision does not agree with the actual speed of block Z after the collision with the data that they give you? So this is because not all energy is conserved in this question. Some lasts to thermal or sound. This is because that the block W is coming at like an angle, maybe, or maybe there's friction question mark. Oh, friction considered to be negligible. Yeah, it might have just lost some energy due to air resistance. Yeah, it could be anything. But yeah, that makes sense because it's not going to maintain all of its energy throughout the whole time.